Good morning, everyone. Today is May 5. We are going to study today type of discontinuity. And before we start, I'm showing you. If you look to my screen, you will find the point of this discontinuity, which is the first one is removable point, because if you look here, your function, you have hole in the top of your function, so we name it as removable discontinuity, because if you simplify your function, it would be x minus 1 multiplied by x minus 1 over x minus 1. So you cancel out what? X minus 1, so it's x is a function x minus 1. So here we remove 1 because the function, the point x equal 1 doesn't belong to your domain, so we name it as removable what? Discontinuity. So now the second point is removable also. You have here hole, and the function is defined far away from your graph. So here also removable discontinuity. We have jump here because the function is jump, like piecewise function. If you have the piecewise function, x plus 1 and x plus 2. So here, sometimes we have jump in your graph. We have infinite, okay, and we are going to make a discussion about each type by using questions. So we are going to make a discussion about how to find rational function point of discontinuity. Okay, so the first question we have, give you function and he ask you select at x negative 4, is it zero function or vertical asymptote or removable discontinuity? And the second point also is x equal negative 2. So before you start, you have to factor your function, like make it in simplest form. If you factor the top, so it's x and x. What's the factor of 8? Yes. 2 and 4. 2 and 4 makes x? Yes. Over x plus 4. You cancel out what here? X plus 4. So at x plus 4 equals 0, you have removable what? So x equal negative 4. You have removable discontinuity. Yes? So at x equal negative 4, you have removable what? Discontinuity. So the second point, x equal to. So what does it mean? At x equal negative 2, your graph here at the function now is equal x plus 2, so it's equal. If you plug in negative 2, so it means at x equal negative 2, your function equals 0. Okay? Original function equals 0. So if you plug in x equal to, sorry, negative 2, make your function equal 0, so x equal negative 2. At this point, because the numerator equals 0, so it's what? Yes, 0. Because if you plug in negative 2, so it's 0 times what? 2 over 2, so it's 0 over 2 equals 0. Does it make sense? And we are going to make another question to more understand. Yes, we have to do the same. What we have to do? Yes, factoring x plus 8. The bottom will be x minus 9 and x plus minus 1. Yes. Are we going to remove any? There is no point of what? Removable discontinuity. Yes, there is no removable discontinuity here. So at x equal 8, it means at x plus 8 equals 0, so x equal negative 8. At x equal negative 8, what you have? Your function will be 0 over a number, so it's what? 0. You have here two vertical assumptions, x equal 9 and x equal 1. So after simplifying, if you have a denominator, if you have any linear function in denominators, like in linear factors, like x minus 9 and x minus 1, so it's x equal 9 and x equal 1. This is what? Vertical assumption. This is not the horizontal one. You understand now how we last time we make a discussion about horizontal, not a vertical one. Okay. Again, one more question. First, factor. Okay, perfect. So if you factor it, x minus 2 and x minus 2. I'm correct? And the bottom, x minus 2 and x plus 1. Cancel out x minus 2. So here you have removable what? At x equal 2. Yes, removable discontinuity. Okay? Now you have x minus 2 over x plus 1. Don't forget at x equal 2, we don't have zeros. Because x equal 2 is removable discontinuity first. Because we write a condition x never equal 2. Yes? Because x equal to is not belong to your domain. So you can't plug in again x equal to your function. So we don't have zeros here, okay? Because at x equal to, we have what? Removable discontinuity. So now we have x plus 2 at the denominator. So we have vertical asymptote at x equal negative 2. We have here, so it's not mentioned here. X equal, sorry, 1, yes, not 1. It's 1 here. After we cancel x minus 2, so it's x plus 1. So at x equal negative 1, we have what? Vertical asymptote. We got it? One more question. Factor your function. X and x, 3 and 7, plus and plus. Over x what? Yes? Good job. X and x. What's the factor of 16? 2 and 8, negative and negative. 3 times 7 is 24, and 3 and 7 is 10. 2 times 8 is 16. 2 and 8 make 10. Okay. Do we have removable discontinuity here? Do we cancel out any? No. So there is no removable discontinuity. This line not included here. So this one is not included. So now we have zeros, yes, at x equal negative 3 and x equal negative 7. So we have zeros at x equal negative 3 and negative 7. We have asymptote, yes, at x equal 2 and x equal 8. Vertical asymptote. Do we have here a removable? No, because we never cancel out. We didn't cancel out any. There is no common factor between top and bottom. Okay, we got it? Okay, please try to finish your assignment and have a great day. See you next class. Bye bye.